a cup of water,
1 small beaker,
1 small platter,
2 small candles,
and a lighter.
First, fill the small platter with water. Then, light the 2 candles.
Next, set the 2 candles in the water and place the beaker on top of them.
Now observe, as the flame heats the air inside the beaker, both the temperature and the pressure go up. However, as the flame is starved of oxygen, it goes out.
Then, as the temperature inside the beaker changes, the water from the platter is pulled up into the beaker, seemingly defying gravity.
Since the formula is directly proportional, as the temperature inside the beaker went down, so did the pressure, which allowed room for the water to be sucked into the beaker. Gay-Lussac's law is P1 over T1 equals P2 over T2, with a constant number of moles and a constant volume. In our experiment, our constants were for volume 100 milliliters or 0.1 liters, and for number of moles 0.0045 moles. The temperature of the burning candle at the beginning of the experiment was 375 Kelvin. Let's say the pressure was 1 atmosphere. The temperature at the end of the experiment was 312 Kelvin inside the beaker. That would make the pressure at the end of the experiment 0.832 atmosphere.
A 1-liter bottle of Diet Coke,
1 balloon,
and 3 Mentos candies.
First, put 3 Mentos inside the balloon.
Then, open the bottle of Diet Coke and quickly fasten the balloon to the top of the bottle, allowing all 3 Mentos to fall into the bottle.
Now observe as the balloon is filled with gas and soda.
The volume of the CO2 gas is directly proportional to the moles of the CO2 gas at a constant temperature and pressure. So when the volume of CO2 gas expands, the amount of moles released into the balloon increases as well.
Notice that after the balloon has finished inflating, the soda drains out while the gas remains inside the balloon.
Avogadro's law formula states that V1 over N1 equals V2 over N2 with a constant temperature and pressure. Our experiment constants were a pressure of 1 atm and a temperature of 297 Kelvin. We know that there are 4.15 grams of CO2 in a 1-liter bottle of Diet Coke. Converted to moles, that's 0.0943 moles of CO2. We also know that there are 0.355 liters of CO2 in a 1 liter bottle of Diet Coke. So if you solve for x, you get 0.376 liters of CO2.